Okay, so this is just one sample question using the new equation, the final velocity equation. Again, just a reminder that we've done all the rearrangement on it, so if you can't remember how to do it, you just go back a video or go back a page and you practice your rearranging, okay? So our question says an airplane starts from rest and accelerates to takeoff speed, which is 70 meters per second. So by the time it gets to 70 meters per second, it's going to lift off the ground. The length of the runway is 2 kilometers and the plane uses the whole runway. So in other words, it travels a full 2 kilometers in order to take off. What's the acceleration of the plane? So if I can just remind you the system that I'm trying to encourage you all to use. The first thing is highlight the important points. So I thought that starts from rest is important, accelerates to takeoff speed, which is 70 meters per second. So that should be my final velocity. My initial velocity should be 0 because it starts from rest. The length of the runway is 2 kilometers, so that's the distance that I've traveled while accelerating. And the plane uses the whole runway. Okay, so at this point now, what I do is I've highlighted my text, I now create my list. Okay, so I list them. Airplane starts from rest, that means the initial velocity is 0. The final velocity of the takeoff speed is 70 meters per second. Acceleration is unknown, and hopefully you can see that I've got the distance. Just one sec, let me change it around. So the distance traveled is 2 kilometers, like we said, but of course that's not an SI unit. So at this point, when it's in the list, that I would do my unit conversion. So 2 kilometers is equal to 2,000 meters. So now I'm ready to go to the next part. Okay, I've made my list, highlighted my text, I'm ready to move on. Okay, so from here I'm going to do this in two methods. Method 1, I'm going to use a very general method that will work for every calculation. So I rearrange my equation first. One sec. So my starting point is my final velocity equation. I'm going to, again, make A my subject. So just a little recap from before. I'm looking around it. The u squared is adding to it, so I'm going to subtract it from one side. If I subtract it from one side, I must subtract it from the other side. That gives me the final squared equal to the initial velocity squared equal to twice the acceleration times the distance traveled while accelerating. Again, I'm just reminding myself that A is my subject here, so I put a little ring around it. I have a look at the 2 and the S. I realize that they're both multiplying. I divide by 2 and S. Those two will cancel on the right, and I'm left with acceleration equal to V squared minus U squared over twice the distance traveled while accelerating. So at this stage now that I plug in my numbers, my final velocity is 70 meters per second. My initial was 0. The 2 is just 2, and the total distance traveled was 2,000 meters. I just decided to evaluate those numbers, and that gave me 4,900 divided by 4,000, which gave me an acceleration of 1.225 meters per second squared. So now I'm going to do it just using a slightly simpler method that won't work for every calculation, but it will work for this one. Okay, so method 2 is what I call plug the numbers in and hope for the best. It won't work for every calculation, but it should work for some of them. Okay, so this could be useful if you struggle with algebra. Okay, so I'm just going to plug my numbers straight in. I know my initial velocity, or my final takeoff velocity is 70 meters per second. So I'm just going to plug that in. That gives me 70 meters per second all squared equal to 0 squared, which was my initial velocity because it was at rest, plus twice the acceleration times the distance traveled, which was 2,000 meters. I evaluate on the left, and that gives me 4,900 equal to, the 0 is gone, twice the acceleration times 2,000. I evaluate on the right, and that gives me 4,000 times the acceleration equal to 4,900 on the left. Last step is the only bit of algebra that I have to do here. and that is to divide both sides by 4,000, okay, because that 4,000 is multiplying the A. Dividing both sides by 4,000 gives me 4,900 divided by 4,000. The acceleration is equal to 1.225 meters per second squared. So still wind up with the same answer. Like I said, this method won't work, may not work for everything. Okay, I do recommend that you learn how to use algebra and you learn how to manipulate formulas in your calculations. But this one should work so long as you are careful with how you do it and you don't do anything illegal in terms of algebra. Okay, but it should work fine. So hopefully I've done enough explanation on this part of the final velocity equation. Again, try to follow our system, highlight the key information, make a list, write your formula, rearrange it if you can, otherwise plug in the numbers and hope for the best, and then you will have a little bit less rearranging to do. Okay, hopefully this is enough for you guys to complete your worksheet. Best of luck with this.